So hello everyone, our project is Sales Forecasting. It is a group project by SHWETA Pandeey, SHEFALI Chaudhary and SAKSHI Virmani. So what is sales forecasting? Sales forecasting is the process of estimating future revenue by predicting the amount of product or services a sales unit, which can be an individual, salesperson, a sales team or a company, will sell in the next week, month, quarter or year. So what is the need of sales forecasting? It helps every business to make better business decisions. It helps in overall business planning, budgeting, and risk management. It helps sales teams to achieve their goals by identifying the early warning signals. So, we have used Google Colab for our project. Google Colab is a free Jupyter notebook environment that runs entirely in the cloud. It does not require any setup. We have done our project in Python language. The basic libraries used in our project are NumPy, Pandas, Matplotlib. NumPy is a Python library used for working with arrays. Pandas is a Python library used for working with datasets. It has functions for analyzing, cleaning, exploring, and manipulating data. Matplotlib is a cross-platform data visualization and graphical plotting library for Python and its numerical extension NumPy. We have downloaded the dataset from Kaggle. The techniques used in our project are Aremax and Serimax. So now we will see the implementation part. So this is Google Colab. In Google Colab, we can open notebook. We can create a new notebook also. We can upload notebooks. We can rename them. Also save a copy in Drive. We can edit them also. We can insert code cell and text cell also. We can run them. And we can also report a bug and send feedback. So in our project we have used ARIMA and seasonal ARIMA. So the full form of ARIMA is Auto-Regressive, Integrated and Moving Averages. It has three modules. The first one is Auto-Regressive, the second one is Integrated and the third one is Moving Averages. So the general process for ARIMA model is that we first have to visualize the time series data. Then we have to make the time series data stationary. Then we plot the correlation and autocorrelation charts and then construct the ARIMA model or seasonal ARIMA model based on the data. And finally, we use the model to make predictions. So first we have imported the required libraries like NumPy, Pandas, Matplotlib. We are loading the data into data frame. For importing the dataset, we have used read CSV. Now we are cleaning up the data with not a number entries for sales column. After cleaning up the data, we have to convert month into date time. Now we have described the dataset. The results are shown below. Now we visualize the data. As mentioned previously, before we can build a model, we must ensure that the time series is stationary. So we have used add fuller function. It has four attributes. The first one is ADF test statistics, the second one is p-value, the third one is lags used, and the fourth one is number of observation used in our dataset. Then we concatenate the result and labels. If the value of result is less than or equal to 0.05, then it is a strong evidence against null hypothesis. So, reject the null hypothesis. Data has no unit root and is stationary. Otherwise, it is a weak evidence against null hypothesis. Time series has a unit root indicating it is non-stationary. So, the value of p-value is 0.36. So, it is not less than 0.05. So, it is a weak evidence against null hypothesis. Time series has a unit root indicating it is non-stationary. So now we do the differencing. Differencing is a transformation applied to time series data in order to make it stationary. This allows the properties do not depend on the time of observation, eliminating trend, and stabilizing the mean of the time series. So, first we will shift it by 1. As it is seasonal data, so we will shift it by 12. Now, the p-value is this much. As we can see that p-value is less than 0.05. So, the null hypothesis is rejected and the time series is stationary. So, these are the autocorrelation and partial correlation graphs. So now we will see the forecasting using ARIMA. So we can see that using ARIMA we can also forecast the sales. So the blue line shows the actual sales and the orange line shows the predicted sales by ARIMA model. So now we will see how to predict the future sales. So we will create a new dataset for future also, and then we will combine the old dataset with the new one, and using that dataset we can also predict the future sales. So this is the implementation part of our project. Thank you.